In today's experiment, we shall work with conical pendulum. Here, mass m is fixed at the end of a string of length L. String mass is negligible. The other end of the string is connected to a pivot which is free to rotate. The mass moves in a circular path of a constant radius rho. In this situation, string makes an angle alpha with the vertical. We shall be evaluating the angular momentum of the conical pendulum about the center of the circular path of the pendulum. Let us say we denote this by vector LA. The angular momentum is given by rho cross P, where rho is going to be rho cap is a position vector. It is always in rho cap direction. The linear momentum P can be written as mv, and its direction will be always in theta cap direction. V can also be written as omega rho. So the angular momentum is going to be m omega rho square k cap. So we see that angular momentum about the center of the circular path is a constant vector. Its magnitude and direction does not change with time. Can we conclude the same when we estimate the angular momentum about pivot point? The answer is no. It turns out a time varying vector. This you can try yourself. Let us concentrate our today's discussion for the angular momentum about the center of circular path. We want to know what will happen when we change the length of the string. Will the angular velocity of the pendulum change? Will it increase or decrease? What is going to happen to angle alpha? Will it also change? So let us see all this in our experiment. So here is our experimental setup. We have taken a cricket ball as our mass, which is roughly about 155 gram. Our string is a nylon string used in fishing. Our rotating pivot point is the axle of exhaust fan without its blade. The length of the string we shall be fixing by our choices, which we can change during the experiment. The angular velocity of the pendulum we shall be estimating by measuring the time period by the timer put on the screen. The rate cone is just a guide to the eye. Now let us see this thing in slow motion and note down the time period. It turns out to be nearly 2 seconds. Now let us change the length and see once again in slow motion. So what we see is that this time it is much smaller, 1.15 second. So we can see that angular velocity has increased, and we can also observe that angle alpha which this cone is making has also increased. Both these changes are expected in conservation of angular momentum. As we go back and see our expression, we can see that rho can be written as L sine alpha. So in our case, when we decrease L, omega increases, as well as alpha increases, and which we can see in our experiment clearly. That finishes today's experiment.